Hi. You would like to be on the safe side with regard to corrosion testing, but have no chemist or metallurgist available? I will show you today how you can shrink the competence of a whole metallurgic laboratory into a 5-cent coin. Hi. In one of our last videos, I showed you a real case scenario with regard to corrosion. In this scenario, or in this video, we were using the ASTM G61 method which supplies qualitative and quantitative test results. This is certainly mandatory in order to optimize process parameters for example, electropolishing or other processes. However, if you are a QA employee and responsible for incoming inspection in an OEM or an installation company, you may not be interested really in a quantitative value of corrosion parameters. What you would actually need is a good or bad test. You would need to have a test that tells you if the corresponding material you're testing is suitable or not. If the passive layer of the stainless steel components you want to handle are okay or not. In order to tell that, there are different qualitative tests available, and the question is, what kind of test can you use? For example, you can have access to the Ferroxul test. In this test, you treat certain stainless steel surfaces with certain chemicals. The question is, if you are a chemist, a metallurgist, and if you are able to handle these chemicals correctly. Because if not, such chemicals might cause problematic reactions that might lead into also toxic chemical contamination of your working area. So the question is, what if a test would be available that shrinks the space which is needed in order to perform this test into a 5-cent coin? Such a test exists and has been developed by the German Federal Institute of Material Testing, the BAM. Dockweiler is also using this test since quite some time, and we believe that this is really worthwhile talking about that here, because it gives you a very easy handling of such a test, and it gives you the same qualitative and sensitivity of the Ferroxul test as you may know. The question is, how does it work? With regard to the Coropat testing, what you receive from the Federal Institute of Material Testing is such a thermal box here with the related Coropats inside. When you look inside, you can take them out. You can see that they are coming with such thermal pads here because they need to stay cool up to roughly 8°C. What also comes with it are the corresponding materials, the corresponding test instructions, as you see in this case, and also some paperwork that describes the procedure in detail. Furthermore, all the material is coming that you need for the test. Some applicator made from plastic and also rubber gloves that protect from the chemicals. Because all these chemicals that you may need for the test are implemented into the gel pad. And as you can see in this short demo here, you see that defects which might be existing in the passive layer are, let's say, detected by the gel pad and that all the chemicals inside the gel pad cause this reaction that will lead to the indication of a failure in the passive layer. These little blue points that you see up there are the indication that you have a defect in the passive layer. That's what I actually want to tell you here today, that really a simple method, very sensitive, is existing in order to solve the question, is a surface good or bad, exists and is very easy to use, more or less for everybody. I hope I could show you the details of it and would certainly be happy about further questions from your side, and I would be certainly very happy as well if you would subscribe to our YouTube channel for some of our next videos. Thanks a lot and stay healthy. Take care.